Hello, this is Math 2270 Differential Equations coming to you from the College of DuPage for the fall term 2020, and this lecture is entitled Course Specific Introductions Continued. One of the very nice things about studying differential equations is the sense of historical legacy that is here. We will talk about the works involving Newton, Leibniz, Euler, Bernoulli, Laplace, Lagrange, Legendre, Cauchy, Bessel, Fourier, and others. The list goes on and on. The formal course description reads this way: equations of first order and applications, homogeneous linear equations of higher order with constant coefficients, non-homogeneous linear equations of higher order with constant coefficients, Laplace transform methods, applications of higher order differential equations, linear equations with variable coefficients, power series solutions, systems of linear equations, and numerical solutions of first order equations. This is the course you signed up for at a minimum. These topics will be covered. Other topics may indeed be covered, and I'm working hard to make sure you get your money's worth. Less formally, differential equations have a remarkable ability to predict the world around us. They are used in a wide variety of disciplines: biology, economics, physics, chemistry, and engineering, and they can describe exponential growth and decay, the population growth of species, or the change in investment over time. We'll talk about many kinds of differential equations and solution techniques, and they are useful in medicine for modeling the spread of disease, in engineering for describing the movement of electricity, in chemistry modeling chemical reactions, in economics for finding optimum investment strategies, and in physics to describe the motion of waves, pendulums, or chaotic systems. These are our learning objectives. Notice that there's a pronounced bias for action verbs, and this bias will be reflected in the assessments. I will check to see if you can solve things, determine, construct, solve, develop. Again, action verbs. And this is the topics that we will cover. Some things will be mandatory, shown in red. Other things are optional, shown in blue. We'll do both red and blue, and the order of coverage will potentially deviate from both the textbook and from this list. I'll let you know where we are and somewhat where we're going, but stay engaged so that you're plugged into this. This is the course you enrolled in. It is called a NET delivery course, and NET stands for Online Asynchronous. This instructional mode allows students to engage in the class at any time of the day, so long as certain deadlines for the completion of work are met. Asynchronous online courses typically rely on tools such as pre-recorded lectures and discussion forums. It is especially appropriate for students who need increased flexibility with their schedules. Interaction within the class can be accomplished through discussion boards, emails, and other means, such as office hours. An asynchronous class can be self-paced but can also have deadlines. We will have some deadlines. This mode of delivery also provides increased flexibility for the instructor, and I am very prone to exercise this flexibility. Lectures will be posted at various times and announced via course announcements and emails. Although I will strive not to abuse this privilege, the students must understand it is incumbent upon them to pay strict attention to these notices and the information that I share this way. This is the academic calendar. We will start here and we will end here, but for NET courses, this is somewhat less important. There are some deadlines you may want to pay attention to, though, like drop deadlines and those kind of things. So do look at this, but realize it is less important for NET courses. Similarly, the final exam schedule, although we will take the final exam during final week, this schedule actually only applies to VCM sections, not NET sections, so it's in large measure irrelevant for you. So we will start on August 24th and we will finish sometime in mid-December. And my tentative targets for the midterm are October 14th and for the final is December 15th. But stay tuned because those might change. I am still negotiating those with the testing center. Our textbook is a first course in differential equations by Dennis Zill. That's what he looks like. And we are using what is called the Classic 5th edition. The reason we use the Classic 5th edition is it covers exactly what we want to cover, nothing more and nothing less. We will do these topics and more to be determined. The pedagogy and approach will be blue collar in nature. Although we will talk some about proofs, the big expectation is going to be with respect to conceptual understanding, critical thinking, computational competence, and applications. And all of these things will be subjects for the assessments that we do. And the applications will include a serious study of projectile motion with respect to initial and environmental conditions. And so we won't just simulate this environment, we'll actually do predictive modeling with respect to this. And so we're pretty much prepared to begin. You should understand the road is straight. It's a long road and some of it will be uphill, but the goal is a very valuable goal. So I'm looking forward to this journey with you. In closing, now more than ever, remember time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. God bless you all.